Assalamu alaikum students, hope you all are fine. I am your teacher Afifa and this is the lecture of physics for class 8th. Today we will do chapter 2. This is the outline of today's lecture. In this lecture we will use physics book for 9th class from Karwan Book House, Lahore. So open page number 44 of your books. Equations of motion. Previously we have studied the graphical analysis of motion, but now we will use mathematical equations to study the motion of a body. Students, do you know why we study equation of motion? What they basically tell us? Equation of motion helps us to find out the acceleration and the distance traveled by the body. In this lecture you will study which equation helps us to find out acceleration and which one is used to find out the distance traveled by the body. In these equations we will relate initial velocity, final velocity, acceleration, time and the distance covered by the body. These terms will be used, and these equation of motions are specifically for the bodies moving with uniform acceleration. It is applicable only in those cases where the body is moving with uniform acceleration. And we have made an assumption here that the motion of a body or its movement is along a straight line. Obviously when the body is moving in a straight line there is no change in direction, so we can ignore the factor of direction and we will use only magnitude of displacement, velocities and acceleration. For equations of motion we will use speed time graph. As you can see, on x-axis we have time and on y-axis we have velocity. This graph will give us acceleration, and the distance covered by the body can be found by the area under the graph. In this graph, the body is moving with initial velocity vi, and after some acceleration it has reached final velocity during time t. And if we want to find out the slope, it will give us acceleration of the body, and the area under this graph will give us the total distance traveled by the body. We will use this graph to find out the equation of motions. In first equation of motion, we will find out acceleration of the body. This equation is used to find out acceleration of the body from speed time graph. If you remember, the slope of speed time graph gives us the acceleration. So acceleration is equal to slope of AB. What is slope? Slope is vertical change and horizontal change ratio. So it's the ratio between vertical change and horizontal change. Vertically the change is in velocity vi to vf, and from the graph these points are from B to C. This is the vertical change, and horizontally the change is in time from point O to point D. This is the horizontal change. Now we don't know what is the particular value of B to C, so we will use the B to D minus CD, which will give us B to C. So BC is equal to BD, this total length, minus CD, we will definitely get BC. So BC is equal to BD minus CD. From this graph, BD is final velocity, CD is the initial velocity, and OD is the time. By putting these values in this equation, we will get acceleration. As you can see, A is equal to Vf minus Vi divided by T. So, by taking T here, AT is equal to Vf minus Vi. So, we will find out Vf is equal to Vi plus AT. This is the first equation of motion, and it is used to find out any of these terms. Second equation of motion. Second equation of motion is used to find out the distance traveled by the body. In this derivation, we will use the same speed time graph. As you know, the area under the graph gives us the total distance traveled by the body. So if you see, we have two geometrical shapes here. This is the triangle and this is the rectangle. So if we will add the area of rectangle and area of triangle, we will get the total area under this graph. So the area of rectangle OACD plus area of triangle ABC will give us the total distance traveled by the body in this graph. Total area of rectangle OACD is length into width, and area of triangle is half into base into height. So in this rectangle, OD is the length and OA is the width, and in this triangle we have AC is the base and BC is the height of this triangle. By putting the values from this graph, OD is equal to D, OA is equal to VI, and AC is equal to T, whereas BC is equal to BD minus CD, which is VF minus VI. By putting all these values in this equation, we will get S is equal to VIT plus half AT square. This is the second equation of motion, which is used to find out the distance traveled by the body. In third equation of motion, we will find out distance traveled by the body with the help of this graph. Here we will use the formula of distance, which is equal to average velocity multiplied by the time, and average velocity is initial velocity plus final velocity divided by 2. As you can see in this graph, OA is the initial velocity and BD is the final velocity. This is the formula for average velocity, and we will multiply it with time. OD in this graph represents the total time. Now to simplify this equation, we will multiply both sides with BC divided by OD. BC divided by OD. By multiplying it on both sides and simplifying it, OD cancels this OD. Here we have OA plus BD multiplied by BC, and here we have 2S multiplied by BC divided by OD. Now we will put the values of these from the graph. 2S multiplied by BC divided by OD is the acceleration, OA is initial velocity, BD is final velocity, and BC is equal to BD minus CD. So from this equation, we will have 2AS is equal to VF square minus VI square. VI plus VF multiplied by VF minus VI gives us VF square minus VI square. So this is the third equation of motion. This is the example 2.10, in which we have a statement: a car is traveling at 10 meter per second, accelerates uniformly at 2 meter per second square, calculate its velocity after 5 seconds. So from this statement, we have a data that there is a car which is moving with initial velocity 10 meter per second. It has accelerated uniformly and the value of acceleration is 2 meter per second. We have to calculate the velocity after 5 seconds, so the time duration is 5 seconds, and we have to find out final velocity. Before solving it, we have to look at the formula list. So this is the basic formulas. S is equal to average velocity into time. Vf is equal to Vi plus At. S is equal to Vit plus half At square. 2As is equal to Vf square minus Vi square. Now we have to analyze this formula list and see which formula will relate to our example and how we can solve it. So we have initial velocity, we have acceleration, we have a time, and we have to find out final velocity. So second formula is suitable, so we will use this formula, and by putting the values in it, we will get final velocity 20 meter per second. Now example 2.11. A train slows down from 80 km per hour with a uniform retardation of 2 meter per second square. How long will it take to attain a speed of 20 km per hour? So in this statement we have a train which is moving with initial velocity of 80 km per hour, and it has a uniform retardation. Retardation means its velocity is decreasing. There is a decrease in velocity, there is deceleration. So the value of retardation is 2 meter per second square. The acceleration is minus 2 meter per second square. Now how long will it take to attain a speed of 20 km per hour? So the final velocity is 20 km per hour, and how much time it will take to reach from 80 km per hour to 20 km per hour. So we have to find out the time, but first we have to see that these values are in SI units. So first we have to convert it into SI unit. So this is the way of converting kilometer per hour into meter per second by multiplying it with 1000 meter and dividing it with 3600 seconds. So we will get the initial velocity 22.2 meter per second, 5.6 meter per second. So this is the formula list. We have initial velocity, we have final velocity, we have acceleration, and we have to find out the time. So the second formula is suitable because we have three factors and we have to find out the fourth one. So we will use this equation, and by arranging it to find out the time, we will get T is equal to Vf. When Vi will go there, it will become minus Vi and divided by A. This A will comes to the denominator. By putting the values, we will get time is equal to 8.3 seconds. Example 2.12. A bicycle accelerates at 1 meter per second square from an initial velocity of 4 meter per second for 10 seconds. Find the distance moved by it during this interval of time. In this statement, we have a bicycle which is accelerating at 1 meter per second square. So its acceleration is 1 meter per second square from an initial velocity of 4 meter per second. Its initial velocity is 4 meter per second for 10 seconds. The time it has taken is 10 seconds. Find the distance moved by it during this interval of time. So here we have to find out the distance. Now look at the formula list. From all these three formulas, we have to choose according to the data that which one is suitable for finding the distance. So third formula is suitable because we have initial velocity, we have time, and we have acceleration as well. So we can easily find out the distance. So S is equal to VIT plus half AT square. By putting the values in this formula, we will get distance is equal to 90 meters. Example 2.13. A car travels with a velocity of 5 meters per second. It then accelerates uniformly and travels a distance of 50 meters. If the velocity reached is 15 meters per second, find the acceleration and time to travel this distance. In this statement, we have a car which is traveling with velocity of 5 meters per second. So this is the initial velocity. It then accelerates. The body has, or the car has accelerated uniformly and travels a distance of 50 meters. So we have 50-meter distance which is given here. If the velocity reached is 15 meters per second, after increase in velocity or after acceleration, the final velocity becomes 15 meters per second. Now we have to find out acceleration and the time to travel this distance. Now look at this formula list, and according to given data, we will find out that which formula is suitable for solving this problem and finding the acceleration and time. If we see, we have initial velocity and we have final velocity as well as the distance, and we have to find out acceleration. So by using formula 4, we can easily find out acceleration. So by putting the values in third equation of motion, 2as is equal to vf square minus vi square. By putting the values in it and solving it, we will get acceleration is equal to 2 meters per second square. Now we have to find out the time. So for time, we have initial velocity, final velocity, distance, and now acceleration as well. Now look at this formula list. So according to the given data, the second formula is suitable. Vf is given, vi is given, acceleration is also given. So we can easily find out the time. So by putting the values in this equation, Vf is equal to Vi plus At, we have found time is equal to 5 seconds. Now open page number 54 and you have the exercise for numericals. A train starts from rest. It moves through 1 kilometer in 100 seconds with uniform acceleration. What will be its speed at the end of 100 seconds? In this statement, a train is at rest. When something is at rest, it means it is not moving. So initial velocity of the train is 0 meter per second. It moves through 1 kilometer in 100 seconds. So the distance is 1 kilometer and the time is 100 seconds. To convert kilometer into meter, we will multiply 1 with 1000 because by putting the value of kilo here, so we will get distance 100 meter. Now we have to find out final velocity. This is the formula list. So according to given data, we will use the first formula. S is equal to average velocity multiplied by the time. We will put average velocity formula Vf plus Vi divided by 2 multiplied by the time. By putting the values in it, 2 multiplied by 1000 divided by 100 is equal to Vf plus 0 meter per second. So we will get final velocity 20 meter per second. Problem 2.3. A car has traveled a velocity of 10 meter per second. It accelerates at 0.2 meter per second square for half minute. Find the distance traveled during this time and the final velocity of the car. In this statement, a car has initial velocity of 10 meter per second. It accelerated and its acceleration is 0.2 meter per second square for half minute. Half minute means we have 30 seconds. The time is 30 seconds. We have to find out the distance traveled during this time and the final velocity of the car. This is the formula list and we will choose the formula according to the given data. So to find out the distance, third formula is suitable because initial velocity, time and acceleration, all these three things are given. So we can easily find out distance by putting the values in it and solving it. We will get s is equal to 390 meters. Now to find out the velocity, we will use the formula Vf is equal to Vi plus 80 and final velocity will be 16 meter per second. Problem 2.5. A car moves with uniform velocity of 40 meter per second for 5 seconds. It comes to rest in the next 10 seconds with uniform deceleration. We have to find out deceleration, total distance traveled by the car. In this statement, the initial velocity is 40 meter per second. The time is 5 seconds for when the body has reached its 40 meter per second. It comes to rest in next 10 seconds with uniform deceleration. When the body has deaccelerated and comes to rest, it means its final velocity becomes 0 meter per second and the time 2 or second time in which the velocity has become from 40 meter per second to 0 meter per second is 10 seconds. Here we have to find out deceleration and the total distance. S1 is the distance for first 5 seconds and S2 is the distance which the car has covered for next 10 seconds. Now by using the formula Vf is equal to Vi plus 80, from this formula we will get acceleration. Acceleration is minus 4 meter per second square. The minus sign is showing that the velocity of the body is decreasing. And to find out the distance, we will use the formula here S is equal to Vt. Why we have chosen this formula? Because initially we have a time and the velocity from 0 to 40 meter per second. So by putting the values we will get 200 meters. Now to find out the final velocity or the distance, we will use this equation 2as is equal to Vf square minus Vi square, and by putting the values in it we will get 200 meter and the total distance will be S1 plus S2 which is equal to 400 meters. Problem 2.6. A train starts from rest with an acceleration of 0.5 meter per second square. Find its speeds in kilometer per hour when it has moved through 100 meters. In this statement, we have initial velocity 0 meter per second because a train has started from rest. When something is at rest, its initial velocity is 0. Its acceleration is 0.5 meter per second square. We have to find out its speed when it has moved through 100 meter. So we have to find out final velocity. This is the formula list and according to the given data we will use the formula 4. By putting the values in it we will get Vf is equal to 10 meter per second. Now we have to convert it into kilometer per hour. So to convert it into kilometer per hour we will multiply this 10 meter per second with 3600 and divide it with 1000. So we will get the velocity 36 kilometer per hour. Problem 2.7. A train starting from rest accelerates uniformly and attains a velocity 48 km per hour in 2 minutes. It travels at this speed for 5 minutes. Finally, it moves with uniform retardation and is stopped after 3 minutes. Find the total distance traveled by the train. In this statement, we have a train which is started from rest, so its initial velocity is 0 meter per second. It accelerates uniformly and attains a velocity 48 km per hour in 2 minutes. So its final velocity is 48 km per hour and the first time duration is 2 minutes. So the time 1 is 2 minutes. We will convert it into seconds and we will get 120 seconds. After these 2 minutes, the train has traveled with same velocity for 5 minutes. So the time 2 is 300 seconds. Finally, it moves with uniform retardation. After that, the acceleration happened and the body's velocity started to decrease and it stopped after 3 minutes. So after 3 minutes, the final velocity becomes 0 for these 3 minutes. So time 3 will be 180 seconds. We have to find out the total distance traveled by the train. S1 for these 2 minutes, S2 for these 5 minutes and S3 for these 3 minutes. This is the formula list. We will use this formula. Formula 1, S is equal to average velocity multiplied by the time. So for distance 1, we will put the value T1 and in this case we have final velocity is 48 km per hour. It is not in SI unit, so we have to convert it into meter per second, and after conversion we got final velocity 13.33. So by putting the values in it and solving it, we will get S1 is equal to 800 meter. For S2 for 5 minutes we have the velocity 13.33. See this statement, it travels at this speed for 5 minutes. So the speed is 13.33 meter per second. So by putting the values in this formula for distance 2, we will get 4000 meter. Now come to the last 3 minutes in which the train has stopped from 48 km per hour to 0. So from 13.33 meter per second, its velocity becomes to 0. So final velocity is 0 for this case and initial velocity is 13.33 and the time duration is 180 seconds. So by putting the values in this formula, we will get 1200 meters. Now to find out the total distance, we will add S1, S2 and S3 and the total distance is 6000 meters. In exercise question 2.13, you have to find out the equations of motion with proper derivation, and in this lecture we have derived the whole equation of motions. So for this solution of this question, you can see those derivations. Thank you so much.